Hello, and welcome back to the Shellcode Obfuscation series here at Red Siege. In today's installment, we're going to be taking a look at Base64 encoding. We're going to take a look at how it works and see if it's very effective. So, without any further ado, let's switch over to our VM and take a look at it. So, Base64 encoding is relatively simple to do. We could use a program to do it for us, but we can also just use the command line to do it. So, you can see here, I'm going to run the command base64 W0, and then give it my shellcode file that I generated with Metasploit. Now, notice I used W0. That's to turn off line wrapping so that it's formatted correctly. So here we go. I've got some base64 encoded data. Starts with /eid, ends with 1q equal. And that's it. That's all we need to do to base64 encode this shellcode. We could do the same thing with it seems to want that met.bin file here, not a very robust program. So you can see that it prints out the same data. It just prints it out as a binary string here. So it's the same thing. Now, what we're going to do is take a look at a C# program. We have been looking at C here mainly, but we're going to take a look at C# because it just makes it a lot easier to work with base64 encoded data. So here's our string of base64 encoded data. It's called S, and you can see it starts with that /eid, ends with 1q equal. To convert that into bytes, all we need to do is convert from base64 string. And now it's in a byte array. So we could take this byte array here and copy it into a buffer that we allocate and execute it right away. No problems at all. So let's take a look at it. So it prints out the output here, and this happens to be FC4883. That's what's happening here. You remember the last two bytes were FF and D5, and that's 255, 213, that's FFD5. So these are our shellcode bytes. It's just printing them out as ints rather than in the hex characters that we're used to seeing. So let's see if it works very well. No surprise for anyone that's seen, uh, someone who has seen Base64 before, you'll know that this probably is not very effective. And if we look at where the end bytes are in the detection, you can see right here at the end, we've got this equal. So each of the characters in that string actually has a null byte in between them. But we can see if we're looking at it, 1q equal, C101 or LB/1q equal. And if we go back and take a look here, C10LB/1q equal. So that is definitely our shellcode that's being detected here. Not really a surprise. Base64 encoding is just a way of encoding data. It's really good at reducing entropy. It is not good at obfuscating things. It's good for obfuscating things visually. Someone looking at that data wouldn't understand what it was right away, but it is not a good means of actually hiding things. Base64 is not encryption, it's encoding, and it's just a good way of really making things that we can transport them because we can take binary data and then just transport it in text without having to do a whole lot of messing around. But it is not effective obfuscation. It is not effective in encryption. You can see here 22 engines detected this, a lot of engines, nearly a third detected this as some type of malicious payload. They understood that this was Metasploit shellcode. So there you have it. That will wrap up our installment on Base64 encoding. Just remember, it's good for lowering entropy. It's good for transporting binary data in a text world, but it is not good for obfuscating your shellcode. Thanks, and we'll see you next time.